each of the following questions consists of 6 statements followed by options consisting of 3 statements put together in a specific order. Choose the options that indicate a combination where the third statement can be logically deduced from the first 2 statements, and that option will be your answer. Alright, so he says each of the following questions consist of 6 statements. You can see that the first question has got 6 statements, right? 1, 2, 3, 4, 5 and 6. And so has the second question, right? 1, 2, 3, 4, 5 and 6. So each option has got, each question here has got 6 statements followed by options which consist of 3 statements. And these have been put together in a specific order. Like look at the options. Option A here has got 3 statements, 2, 3, 4. Option B has got 3 statements, right? 6, 1 and 5. And there is a specific order here, right? 6 followed by 1 followed by 5. 4 followed by 2 followed by 3, right? 4 followed by 3 followed by 2. Now we have to choose the options that indicate a combination, right? We have to choose that option where the third statement can be logically deduced from the first 2 statements. So from these combinations, from which of these combinations can we find that the third statement can be logically deduced from the first 2 statements? So let's say you're looking at option B here. Option B has got 6, 1 and 5. So this is the first statement, second statement and third statement. I mean, again, be careful. When I say first, second, third, I don't mean that the first statement here, second one here and third one here, right? The first, second, third in that order of option B, right? So the third statement, which is statement 5, can be logically deduced from the first 2 statements, which is statement 6 and statement 1. And if that happens, option B will be our answer. Otherwise, we'll have to go for the next one. So let's try it out. Look at first one. First question. What are the statements? Some P is Q, all Q is R, no R is S, some S are Q, all Q are T, some T are P, right? So standard statements, nothing worth highlighting there. Now look at option A. Option A has got 2, 3, 4. Option A here has got 2, 3, 4. So we have to check if statement 4 can be logically concluded from 1 and 3 together. Can 4 be concluded from 1 and 3? How do we do that? Just draw the Venn diagram very quickly, right? I'm sure the diagrams would be very simple, right? So 2 and 3, draw the diagram for 2 and 3. How will it look like? All Q is R. All Q is R. All Q is R. No R is S. No R is S. You see, all Q is R, no R is S. All Q are R and no R is S. No R is S. What is the fourth statement? Look at the fourth statement. Some S are Q. Some S are Q. Can some S be Q? No. Because S cannot go inside R. If S cannot go inside R, how can S be Q? Some S are Q would be a wrong conclusion. So A does not satisfy. Now do it for B. B has got 6, 1 and 5. What is 6? Some T are P. Some T are P. And then followed by 1. 1 is some P are Q. Some P are Q. 6. Some T are P. Some T are P. And 1. Some P are Q. Now look at the fifth one. The fifth conclusion. What is the fifth conclusion? All Q are T. Do you find all Q to be T here? No. So option B also is wrong. Look at option C then. 4, 2. 4 and 2. So draw the basic diagram for 4 and 2 first. Statement 4. Some S are Q. Some S are Q. Right? Some S are Q. What is 2? All Q is R. All Q is R. Getting it? Statement 4 says some S are Q. We have got the diagram for that. Statement 2 here mentions all Q is R. All Q is R. So all Q should be R. Now the statement 3, which is the conclusion, which is supposedly the conclusion for 4 and 2 together, right? So what is statement 3? No R is S. No R is S. Fails. It fails in the basic diagram itself, right? We can very clearly conclude that some R are S, right? There's an overlapping between R and S. So some R are S. But here it says no R is S. So C also is wrong. And D. What is D? 4, 3, 2. 4, 3, 2. So draw the diagram for 4 and 3. Some S are Q. 4 is some S are Q. 4 and then 3. No R is S. No R is S. So R and S would not overlap with each other, right? Some S are Q. No R is S. No R is S. Now what is the second conclusion here? All Q is R. All Q is R. No, it fails in the basic diagram itself. So A, B, C and D are wrong. Hence none is correct. Option E should be the answer. Similarly, do it for the next one, right? Let's do it for the next one. Same 6 statements. There have been some combinations given to us in the options. We have to find out in which of these combinations the third statement can be logically deduced from the first 2 statements. So option A has got 1, 5, 3. 1 is what? Some M is N. Some M is N, right? Some M is N. 5. Some R is M. Some R is M. Some R is M. So some M is N. Some R is M. Now 3 says no X is R. X does not even come into picture. I mean, even without drawing the diagram, we can actually say that 3 would not follow. Because see, 1 has got M and N as the, subjects there. 5 has got R and M. So M, N, R. We are talking about M, N and R. But the conclusion here is talking about X, which is not there in the statements at all. So how can this be the answer? Not possible. Similarly, 5, 4, 6. Let's see if 5, 4, I mean, if you want, you can quickly verify whether the variables are matching or not. 5 has got RM, 4 has got YM, and 6 has got NY. So again, I think directly we can cancel this out. You're able to follow. If you see, statement 5 has got R and M. This is talking about RM. Statement 4 is talking about Y and M. So basically, if you combine the two statements together, we have got R, M and Y. Right? We have got R, M, Y. But the conclusion, which is statement 4, is talking about, conclusion, this is statement 6, sorry. Statement 6 is talking about N and Y. N is not even there in our statements. So B is wrong. Similarly, check for C. See, why are we doing this verification? Because options can be eliminated directly, right? We don't even have to draw the diagram. Check for C. 1 has got MN, 6 has got NY. So M and Y are the variables, and 4 has got Y and M. So possible. Let's check. C. Sum M is N. Sum M is N. Sum M is N, right? From statement 1. 6. All N is Y. All N is Y. Sum M is N. All N is Y. Sum M is N. All N is Y. All N is Y. And then the conclusion for these two, according to option C, should be statement 4. What is statement 4? Sum Y is M. Do we find that to be correct? Sum Y is M? Yes. Sum Y is M. Yes. It follows the basic diagram. And you all know that it will follow all the possible diagrams as well. This is a basic standard question type, right? Where some A's are B's, all B's C. So when you show some A's are B's and all B's C, definitely some C's will be A's, right? So I think option C satisfies the given condition. What is that condition? The third statement in the combination can be logically deduced from the first two statements of the combination, right? So option C is the correct answer. And we don't have to verify D here, right? Don't waste your time. So I think syllogism itself, but presented in a different format. Okay. It says each question consists of 6 statements followed by 5 conclusions. Consider the given statements to be true even if they seem to be at variance with commonly known facts. Read all the conclusions, then decide which of the given conclusions does not logically follow from the given statements using all the statements together. So I think what all you have to pay attention to, I mean, you don't have to read the full direction there. I mean, I say read directions, I don't mean to say that read the full direction, because most of the part here is known to us. All this is not required, right? That given statements are true even if they seem to be at variance from these things are known to us already, right? Read all the conclusions. This anyway is given. What you have to really pay attention to is whether you have to find out conclusions which logically follow or conclusions which do not follow. Yeah. So selective reading is very important, right? You should know what part to be read and what part to be skipped. All this has been highlighted in red. All which has been highlighted in red is not needed. It's a waste of time. It's just a waste of time. This is very, very important. Okay. Anyway, so important learning here, read the question properly. I'm sure many of you did not read it properly. Now, statements. Some balls are toys, right? So let me draw the basic diagram first. Some balls are toys. Okay. Some balls are toys. So these are balls, let's say. Some balls are toys. No toy is a car. No toy is a car. No toy is a car. All cars is teddy bear. All cars is teddy bear. Okay. No teddy bear is pink. No teddy bear is pink. I'm just drawing the basic diagram. I'm sure you know the technique, right? You know how to draw basic diagram. We have discussed this in our videos. Just follow that. Some pink are blocks. Some pink are blocks. Some pink are blocks. I think you have to be careful, right? These are balls. Remember, and these are blocks, right? And then all blocks are buildings. All blocks are buildings. All blocks are buildings. So be careful again, right? This is the basic diagram. This is the basic diagram for the given question. Some balls are toys. No toy is a car. Toys and cars. So one cross mark here, one cross mark indicate here. T and C cannot touch each other. All cars is the teddy bear. All cars is the teddy bear. No teddy bear is pink. So teddy bears and pink will not overlap with each other, right? No teddy bear is a pink. Now why have I put double cross here? I can put single cross also. Single. But then the confusion will be, how do you pair it? Now it's very clear that single here and double here. So pink cannot touch teddy bear, but pink can go and touch toys. Pink can go and touch balls. You're getting it? Pink can overlap with B here. Pink can overlap with T. but pink cannot overlap with TB here. Okay. Next, some pink are blocks, right? This is the overlap here, and all blocks are buildings. So that's the basic diagram. Now look at the conclusions. Some balls is not car. Some balls is not car. True or false? Some balls is not car. True. As per the basic diagram, it is true. Some balls is not car. But the question that arises is, will it always be true? Remember, a conclusion is definitely true if and only if it follows not only the basic diagram but all the possible diagrams. So if a conclusion has cleared the basic diagram, does not mean that it is true. You have to think of the possible diagrams as well. So what's the conclusion here? Some balls is not car. Now yes, according to basic diagram, some balls is not car. We can choose some of these balls and say these are not cars. Now, will it always be true? Logically, it will always be true. How? See, we know that some balls are toys. Some balls are toys, right? Some bees are teas. Obviously, some bees are T's. Always some B's are T's. And no T is C. No T is C. Which means all these T's which are B's cannot be C. So any type of diagram you draw, there will always be some B's. There will always be some B's which are T's. And since these B's are T's, they cannot be C's. So there are always some B's which are not C's. So some B's is not C is correct. This is true. This is true. Second conclusion. All toys being teddy bear is a possibility. Yes, it is possible. Very simple. I mean, you don't even have to draw the diagram. Visualization will help you. I can draw a bigger teddy bear here, which encompasses balls and toys, or only toys, let's say. How does it matter? I'm not violating any of the statements. Let me draw the possible diagram for you, right? One possible way of drawing teddy bear is as follows. Can you not draw teddy bear in this fashion? TB. Let's say TB dash. Nothing wrong, right? We have not gone against the statement. The statement said all cars is teddy bear. Even in this case, all the cars are teddy bear. And no teddy bear is pink. You see, no teddy bear is pink. Satisfied or not? No teddy bear is pink. And in the process, I find that all toys, see, all the toys have become teddy bears. All the toys have become teddy bears. So is it possible? Yes, it is possible. So all toys being teddy bear is a possibility. So B is also true, right? B is also true. This is true. Second, third, no car is a building. No car is a building. Is it true? Well, no car is a building is true. As per the basic diagram, it is true. Car and building do not overlap at all. Car and building do not overlap at all. But will it always be true? No. I can draw a diagram in such a way that buildings overlap with cars. We can draw a diagram in such a way that buildings overlap with cars. Let me show you the possible diagram there. Like for example, let's say I draw, hold on. Let's say I draw buildings. A possible way of drawing buildings. What was the statement? All blocks are buildings, right? All blocks are buildings. Can I not draw buildings like this? Sorry. Can we not draw buildings in this? Sorry. Can we not draw buildings in this fashion? Building dash. What was the statement? All blocks are buildings. Even in this case, all the blocks have come inside buildings. Did I violate any of the statement? No. I'm drawing a bigger building which encompasses everything else, or some part of the diagram. Now what do I find? No car is a building was a statement. But see, cars have become building. All the cars have become building. All the cars have come inside buildings. So how can you say no car is a building? Which means this is wrong. No car is a building is wrong. Yes or no? No car is a building is wrong. While it may satisfy the basic diagram, it fails in the possible diagram, right? So this particular conclusion is wrong. No car is a building is wrong. Now no car is pink. Is it true? No car is pink. Yes, this will be true. This will definitely be true. Why? All the cars are inside teddy bears. And teddy bears cannot overlap with pink. If teddy bears cannot touch pink, how can cars touch pink? You getting it? Teddy bears cannot touch pink. If teddy bears cannot touch pink, cars also cannot touch pink. So no car is pink is correct. Some building is pink. Some building is pink. Yes, I mean forget about the possible buildings here. Look at the basic building. Some building is pink is always true. Yes or no? Because some blocks are pink. Some blocks are pink and all the blocks are buildings. So if all the blocks are buildings, always there will be some buildings which are pink. So some building is pink is always correct. I don't even have to draw the possible diagrams for that, right? It satisfies the basic diagram. It will satisfy the possible diagrams also, right? No doubt about it. So I observe that A, B, D and E are correct. Only C is false. He's asked us to find out which of them does not follow. Which of them does not follow? My answer should be only C does not follow. Only C does not follow. However, I think the options are given in a different fashion, right? Option says only A follows, wrong. Only both B and E follow, wrong. Only C follows, wrong. Only D follows, wrong. None follows is also wrong. You're getting it? See, don't mark none follows here because A, B, D and E follow. The correct answer should be option 6. The correct answer should be option 6, which is none of these. There's a difference in none follows and none of this. None of these. That's the correct answer, right? None of this means only C does not follow. That's what we are taking it as, none of this. So don't mark none follows. None follows means you're saying all the 5 conclusions are wrong. But actually 4 of the conclusions are correct. Only C is wrong, which is not given in any of the options. And hence option 6 is the answer. Some homes are floors is a possibility. Some ships are not cities. Some homes are floors is a possibility and some ships are not cities, right? Some ships are not cities. So I think the easiest way to do is just quickly draw Venn diagrams for the given options and see which option satisfies both the conclusions. So if I look at the first set of options here, first option which has got statements, all floors are antenna, right? All floors are antenna. All floors are antenna. Then all antenna are ships. All antenna are ships. No antenna is a city. No antenna is a city, and no hospital is a ship. And no hospital is a ship. Right? No hospital is a ship. You understand the basic diagram, right? All floors are antenna. All antenna are ships. No antenna is city. So antenna and city will not overlap with each other, and no hospital is ship. Hospitals and ships will also not overlap with each other. So 2 cross marks indicate these 2 circles will not touch each other. Single cross mark indicates these 2 circles wouldn't touch each other. Okay. Now if you observe, just check whether the 2 conclusions given here follow the given diagram or not. So some homes are floors is a possibility. Some homes are floors is a possibility. Is it possible? Some homes are floors? It's not possible here because you see homes cannot touch ships. If homes cannot touch ships, how will it touch anything that is inside ships? Floors and antennas are always going to remain inside ships, right? And homes, it cannot touch ships, hence it cannot touch floors. So saying that some floors are homes, some homes are floors is a possibility would be wrong. It is not possible. So first one fails. We don't even have to look at the second conclusion now, right? From the first conclusion itself, we know that statement 1 is wrong. Look at statement 2, option 2, right? What is option 2? Some floors are antenna. Some floors are antenna. So some floors are antenna. All antenna are ship. All antenna are ship. Then some antenna are city. All antenna are ships. Some floors are antenna. All antenna are ship. Then some antenna are city. Let's say some antenna are city. And no hospital is a ship. No hospital is a ship. So hospital and ship would not touch each other. Hospital and ship will not touch each other, right? So what happens? Look at conclusion number 1. Some homes are floors is a possibility. First conclusion. Some homes are floors is a possibility. Is it possible? Some homes are floors? Well, yes. If you see, it is possible because homes cannot touch ships. Homes should not touch ships. Anything that comes inside ships. But homes can go and touch, the cities and floors here, right? Like for example, homes can also be drawn in this way. Other possible way of drawing homes. One possible way of drawing homes here in this diagram is this one. Because the statement said that no hospital is a ship. Even in this case, no hospital is a ship. We have not violated any of the conditions, right? Hospitals and ships are not touching each other. However, you find that some homes become floor. So some homes being floors is possible when you look at statement 2. Now check the second conclusion. Some ships are not cities. Some ships are not cities. Some ships are not cities. Well, some ships are not cities has been satisfied in the basic diagram again. Some ships are not cities is satisfied here. You can choose all these ships which are outside, right? These ships are not cities, right? Outside ships are not cities. Outside ships are not cities. But will it always satisfy is the question. Will it always satisfy? Will this always satisfy? Some ships are not cities. See, when will some ships not cities become false? When all the ships are cities. And can all the ships be inside cities? Yes, it is possible. How is that possible? Look at the third statement here, right? Some antenna are city. Some antenna are city we have drawn in this way. Some antenna or city has been drawn in this way. But can we also draw the cities in this format? See, forget about this purple C. Look at the blue C. It is a possible diagram, right? Whatever I have drawn in blue here indicates the possible diagram. So if I draw ships in the cities in this way, what was the statement? Some antenna are city. Some antenna are city. Yes, even now some antenna are city. But the fact is, when some antennas or cities are drawn in this way, all the ships are inside cities. All the ships you see have come inside cities. So can we say some ships are not cities? No, some ships are not cities cannot be concluded from this one. Hence, statement 2 also false, is also false, right? Option 2 also fails. Look at option 3 now, right? Option 3. What does it say? All floors are antenna. All floors are antenna. All antenna are ship. All antenna are ship. Some antenna are city. Some antenna are city. And sorry, I think I was reading a wrong set of statements. I'm sorry about that. Yeah. Okay. All floors are antenna. We have drawn this. All antenna are ship. We have drawn this. And no antenna is a city. No antenna is a city. How do you draw? No antenna is a city. No antenna is a city. So antenna is here, city is here. So no antenna is a city. Antennas and cities will not touch each other, right? Antennas and cities will not touch each other. And finally, all homes are ships. All the homes are ships. So all the homes are ships means what? All the homes should be inside ships, right? We are trying to do minimum overlapping. Minimum overlapping. So all the homes are ships. Okay, looks like there's some confusion here. Sorry, I was not looking at the chat. But in the first two, now this was posted by Ram and I think we took it as it is without doing a proper verification. But the point is, in the conclusions given, we are talking about homes. Look at this. Something is wrong here. I just looked at the chat. We're talking about homes, but homes is nowhere given in the statements, right? In fact, we have hospitals in place of homes. But homes is here. Yeah, so does that mean that I could have eliminated, statement 1 and statement 2 directly? Because homes is not even mentioned there. I mean, since I was taking only H for homes, I thought H is hospital and continue doing it. But yeah, if you actually see, strictly speaking, the word homes is not even used in the statements. So how will we verify? Second set of statements also, the word homes is not used. In the third, fourth and fifth one, homes is used. Anyway, we have verified 1 and 2. I think this is an error, right? Hospital should be homes, right? No home is a ship, no home is a ship, etc. But anyway, let's look at third statement now, right? Third statement. So third statement says all floors are antenna, then all antenna are ship, some no antenna is a city, antenna and city do not touch each other, and all homes are ships. All the homes are ships. All the homes are inside ships, right? Remember, we are drawing a basic diagram, so you have to always keep in mind minimum overlapping. Like for example, I can also draw a bigger circle for homes, but why to unnecessarily make homes overlap with antennas or floors here? Try to keep it minimum, right? That's the whole idea. Basic diagram means minimum overlapping. Now check the conclusions quickly. Some homes are floors is a possibility. Some homes are floors is a possibility. Yes, it is possible. See, in the current basic diagram, it is not possible. Homes and floors are not touching each other. But like I said, can we draw bigger homes? Yes, we can draw bigger homes. Instead of drawing, like, what was the statement? All homes are ships. All homes are ships can also be drawn in this way. Possibility, let's say. If you draw all homes are ships in this way, then some homes are floors will become possible. The shaded region, you see the shaded region here. Some homes are floors is a possibility. Yes, it is possible. Then the second thing that we need to verify is some ships are not cities. Some ships are not cities. Is it true? Yes, definitely true. How can we say it is definitely true? See, we know that all the antennas are inside ships. All the antennas here are inside ships. And no antenna can be a city. No antenna can be a city. So definitely there will be some ships. Which ships? All the ships which are antennas, right? See, basically all the antennas are ships. So antennas can be replaced with ships. Antennas, all antennas. What did the statement say? All antenna are ships. So wherever we have antenna, we can actually replace with ship. I gave this technique earlier also, right? When we say all A's are B's, wherever we have A, it can be replaced with B. So all antennas are ships means antenna is equal to ship. Ship is not equal to antenna, but antenna is equal to ship. So wherever we have antenna, we can write ship in that place. So instead of saying no antenna is city, I can say no ship is city. No ship is city. And if I can say no ship is city, then I can say some ships are not cities. Because the definite conclusion for no ship is city is some ships are not cities. Some ships are not cities. We can always prove that these ships are not cities. Right? These ships which are inside antennas are not cities, because antennas and cities cannot overlap. So statement 3 has followed both the given conclusions. Right? Statement 3 has followed both the given conclusions. So I think statement 3 can be taken as a correct answer. Alright. See, it may look lengthy because I am giving a detailed explanation, but when you do it yourself, I am sure you don't have to think about it so much, right? It's all about drawing the basic diagram, right? You should know how to draw basic and possible diagrams, and where to use possible diagram, where not to use possible diagram. All these things have been discussed in our video, right? Syllogism video. So I urge all of you to just go through that and watch it once again. Okay. Now no need to verify fourth and fifth statement because we already got option 3 as answer, but I can see from the chat that statement 5 also follows both the conclusions. So let me check statement 5 once. Somebody has mentioned in the among the students that statement 5 also follows. Well, ideally it should not happen, but let's just check. Fifth one, I'm not drawing fourth one, assuming that it doesn't follow. Look at fifth one. Some floors are antenna. Some floors are antenna. All antenna are ship. All antenna are ship. Some floors are antenna. All antenna are ship. No antenna is city. No antenna is city. So antenna and city do not touch each other. No antenna and city. And some homes are cities. And some homes are cities. Some homes are cities. So this is the basic diagram, right? Basic diagram for option 5. All floors are antenna. Some floors are antenna. All antenna are ship. No antenna is a city. And some homes are cities. Some homes are cities. Now go back to the conclusions. First conclusion. Some homes are floors is a possibility. Some homes are floors is a possibility. Yes, it is possible. See, in the basic diagram, it is not possible. But I can always draw homes in this fashion, right? Like instead of drawing H like this, can we not take H in this fashion? Because the statement said some homes are cities. Some homes are cities. So here also you can find that this overlapping region, right? The shaded region shows that some homes are cities, right? Some homes are cities. And at the same time, you find that homes and floors are also overlapping. If you try to do this possible diagram, you find that homes and floors are overlapping. So can we say some homes are floors is a possibility? Yes. Some homes are floors is a possibility. So the first one follows. First one follows the fifth set of statements. What is the second conclusion? Some ships are not cities. Some ships are not cities. Is that true? Well, yes. Like what we have seen in the previous case, right? In conclusion 3, I mean in statements 3, same is applicable for statement 5 as well. You're getting it? It is the same thing. If you see, I'll highlight two portions here. Try to look at this. All antenna, right, look at this. All antenna are ship, no antenna is city, all homes are ships. Here also all antenna are ship, no antenna is city, some homes are cities. Some homes are cities. Well, so same statements. All antennas are ship, no antenna is city. All antennas are ship, no antenna is city. And because the set of statements is same, I think this conclusion will be followed in fifth case also, right? Some ships are not cities. Some ships are not cities. Which ships will not be cities? Some ships are not cities. So these ships which are antennas will not be cities, because definitely there are antennas inside ships and antennas cannot be cities. So we can say some ships are not cities. Some ships are not cities. So fifth one also satisfies, interestingly. Fourth one I have not verified. I hope it doesn't follow. So now what's the question? How do we decide which is correct? Is it 3 or 4? Is it 3 or 4? Or have we committed a mistake somewhere? Look at 3. All floors are antenna. All antenna are ship. No antenna is city. All homes are ships. All homes are ships. So when I look at the conclusion, some homes are floors is a possibility. Some homes are floors is a possibility. What is wrong in that? Some homes are floors, possibility. Some ships are not cities. Some ships are not cities is also possible. So I think 3 and 5 both satisfy, right? 3 and 5 both satisfy. So Ram, you just have to look at the look at the source of your question here, right? Because I think the answer is option 3 and option 5. The final answer to this question is option 3 and option 5. And it is on reverse syllogism, right? What is reverse syllogism? Usually in syllogism, we are given statements and we have to find out which of the conclusions logically follow the given statements. Yeah. But here in reverse syllogism, we are given the conclusions. The conclusions are true. We have to find out for which of the set of statements will these conclusions be true. Right? So reverse process. Now, no point in drawing the diagram for the conclusions, right? You never draw a diagram for a conclusion. You always draw a diagram for the statements. So look at the conclusions. He says no car is a bike. All bikes being races is a possibility. He's talking about two conclusions where he says no car is a bike and all bikes can be races. All bikes being races is a possibility. So let's check the statements. Yeah. See, very clearly, there are some techniques which can help you eliminate some of the answers directly. Like if you observe the first conclusion here, he says no car is a bike. No car is a bike. Car and bike cannot overlap at all. No car is a bike mean what? Car and bike should not be touching at all. So whatever diagram you draw for the statements, cars and bikes should not be touching at all. No car is a bike. Now just by reading some of the statements, we can eliminate. See, statement 1, The first option here, set of statements, says all cars are bikes. If all cars are bikes, can the conclusion be no car is a bike? No. So it is wrong. Directly eliminated. Similarly, statement 3, all cars are bikes. If all cars are bikes, can the conclusion be no car is a bike? Eliminated. Anywhere else we have all cars are bikes? No. So directly we have been able to eliminate 1 and 3. So this way you can eliminate some of the options. And if you are lucky and able to eliminate, let's say 4 of the options, you are done. Without drawing any diagram, you can conclude that. I mean, you can come to the right answer. You can arrive at the right answer. But anyway, since only 2 of the options have got eliminated, we have to work on this one. Right? How did we eliminate option 1 and option 3? Not option 1 and option 3, but statements 1 and statements 3. Because statements 1 and 3 have got all cars are bikes as one of the statements. If all cars are bikes, then the conclusion cannot be no car is a bike. These are quite opposite, right? So 1 and 3 are eliminated. Now draw the diagram for 2, 4 and 5. Anything else that we can verify? I don't think any direct verification otherwise is possible. So draw the diagram for statements 2. Statements 2. Some matches are bikes. Some matches are bikes. No bike is a race. No bike is a race. Bikes and race do not touch each other. All cars are laps. All laps are races. All laps are races. So I think I'll have to just redraw this in a bigger way, right? 1 second. What is it? All laps are races. All cars are, all laps are races. All cars are laps. So it's like this. All cars are laps. All laps are races. And no bike is a race. So that's a diagram for statements 2, right? What does it say? Some matches are bikes. Some matches are bikes. No bike is a race. See, bike and race do not touch each other. All cars are laps. All the cars are laps. And all laps are races. All the laps are races. Now check whether the 2 conclusions given here satisfy this basic diagram or not, right? We have drawn the basic diagram for second set of statements. So no car is a bike. Is it true? Yes, no car is a bike is true. Because if bikes cannot touch races, bikes will not be able to touch cars. Very clearly, right? If bikes cannot overlap with races, how will bikes ever overlap with cars? Because the moment bike overlaps with cars, it also overlaps with races. So first one follows. First conclusion follows. Second conclusion, all bikes being races is a possibility. Can all the bikes be races? No. I mean, clearly he says bikes and races cannot overlap, right? No bike is a race. No bike is a race. So if no bike is a race, how can we say all bikes being races is a possibility? I think we have got one more way to eliminate the options. Yeah. Now it gives me a clue. See, no bike is a race. If no bike is a race, how can we say all bikes being races are possible? Impossible, right? Bikes and races do not touch at all. So statements 2 also get eliminated. And the moment statements 2 get eliminated, I think statement 4 also get eliminated because it says no bike is a race here. See, when no bike is a race, how can all bikes be races? Let me highlight. Let me use a highlighter here. See, no car is a bike. We eliminated 2 options. All cars are bikes and all cars are bikes. So these 2 options got eliminated because these are not going together, right? Similarly, if you look at the second set, let me use a different color here, right? He says all bikes being races is a possibility. How is it possible when you have given no bike is a race? You have very clearly given that no bike is a race. So how can all bikes be races? Similarly, no bike is a race. How can all bikes be races? Not possible, right? So I think we can directly eliminate 4 options. I mean, like what I had mentioned earlier, right? If you are lucky, you can eliminate 4 options straight. So 1, 2, 3 and 4 have got eliminated. 1, 2, 3 and 4 have got eliminated. Then only 5 is left out, which is not there in the options at all. Yeah, I think the answer should be option 5, none of this. Because the correct answer is, correct answer could be statements 5. Let me check statements 5 by the way. Let me check if statement 5 gives you the answer. All matches are bikes. All matches are bikes. No bike is a lap. No bike is a lap. All cars are laps. All cars are laps. All laps are races. All laps are races. Yeah, that's a diagram for statements 5, right? All matches are bikes. All the matches are bikes. No bike is a lap. No bike is a lap. Yeah. All cars are laps. All laps are races. Now check the 2 conclusions. No car is a bike. Yeah, no car is a bike is correct because bikes cannot overlap with laps. If bikes cannot overlap with laps, bikes cannot go inside laps and overlap with cars. So no car is a bike is true. Yeah. Simple, right? Bikes cannot overlap with laps. So how can bikes overlap with cars? Yeah. Then second conclusion was all bikes being races is possible. All bikes being races is possible. Yes, definitely possible because if I draw races in this fashion, what happens? R dash. Sorry. If you draw races in this fashion, R dash. Any problem? No problem, because statements have not, we have not gone against the statements, right? Statement said all matches are bikes, all the matches are bikes. No bike is a lap, no bike is a lap. All cars are laps, all cars are laps. And all laps are races. So instead of drawing all laps are races in this fashion, we have drawn all laps are races in this fashion. Possible way of drawing races, right? This is a possible way of drawing races, R dash. The moment I draw R dash, all bikes being races becomes possible, right? All the bikes are races. You see, all the bikes have become races. So it is possible. All bikes being races is possible. Yeah? When you consider statements 5, set of statements 5. So I think answer should be option 5, none of this. And the exact answer should be only statements 5. Only statements 5. Yeah. So I think there is an error in the options here. All the 4 given options are wrong. So I am taking 5th option. I am creating a 5th option, which is none of this.